Everyone, welcome back to the next video. In this video I will show you how to apply matrix transformation to a live camera preview in Flutter Android. So we will be applying the dizzy crop effect. So let me show you guys first the output so that you will get a better idea. So again, I'm using Android Studio to mirror my device, so the output might be little bit laggy because I'm mirroring my device. So first here you can see I'll just give the camera permission. Okay, and the app crashed. I don't know why, so I'll just remove the app. I think I was like holding the app for the long time. It was in memory for the long time, that's why I think it's crashed. Let me just run the application. I think it might have ran out of memory, that's why. So yeah, no worries. I think let's just run the application and let's see it one more time. In the meantime, what you need to know is you need to use at least Flutter 3.32.0 or higher, otherwise you will get lot of build Gradle issues. So be careful with that. You need to use at least Flutter 3.32. higher. And second is, all the code which I will be showing you related to camera and applying this effect of matrix transformation is native code. I am not using any third-party library, so be careful with that as well. I think it is taking a bit of time to launch it on my device. In the meantime, we can just go through the code. So here you can see I have this main.dart file. I have imported this dart.io. Here is my camera view file as well. So here I have this my camera view.dart file. So again, that's what I have importing over here. Now this is the Flutter app, my project name. So whatever is your project name, maybe you should add it over here. Don't just copy mine. Okay, then here I have imported material as well as service.dart. Then here I have just literally copy like this is the boilerplate code which is present by default. Then here is our my homepage widget. So it is a stateful widget. Like I said, we are only doing it for Flutter Android, so by default the permission is false. Then here I have created a method channel for getting the camera permission inside the init state. If platform is Android, then we just call this get camera permission. Then here we invoke a method called get camera permission, and whatever result we get, if it is true, then we just update this particular variable to true. And then here we override this build method as well, and here we return scaffold. If permission is granted, then we just create a safe area passing the my camera view, and here we have another safe area where we display the text, and here we just say give camera permission. If the camera permission is granted, this my camera view will be displayed. So here I have created a dart file called my camera view.dart. So here we do dart.io, import Flutter material, Flutter services as well. Here is our stateful widget. Here is our method channel of camera view. Then here we have this image URL which is empty at the start. Then here is our creation params as well. So this creation params is only used for sending data from Flutter side to native Android side. Here we are not really sending anything. Okay, and if platform is Android, and if image URL is not equal to empty, so image URL will not be empty once you have taken a photo. Okay, so now to display the captured photo, we just use this image.file by passing the file image URL, and I'm just set the width and height as well. Else here we display the Android view at the very start, which will display your camera view as well as take photo button. So same name you will have to use it on native Android side as well. And here you can see we have this on platform view created callback. So once we have this callback, we listen for this method handler as well, and once this is called, we keep listening for this key sent from native. And once the image has been captured, we get the URL over here, and we just assign it to this particular variable of image URL. Okay, so my output is ready. Let's go through the output once. So here you can see again I have the camera permission. I'll just give the camera permission. Okay, the app crashed again. I don't know why this is happening. Let me just quickly check the logcat. I just close this failed resolution of didn't find class resolution. Okay, I don't know what this is. This is a very weird issue which I'm facing. This is our matrix transformation factory. Anyways, I'll let's go through the code once. Then after that I'll just check for that error message. So next you will have to go to the Android folder. You will have to go to app build.gradle.kts. Here you need to add this dependencies block, where you need to add Android camera core, Android camera 2, Android camera lifecycle, Android camera view, Android X media 3 effect, which is still in alpha at the time of me recording this video, then Android X media 3 effect, as well as Android X constraint layout. Then you need to go to src main android manifest.xml. then here you need to use uses feature of Android hardware camera, uses feature of Android camera, uses permission of Android camera, as well as write external storage permission. Then you need to go to Kotlin, and firstly you need to create this Java class. So this again, this should be your own package name. To get your package name, you can just go to main activity. Here you will see your package name. You can just copy paste the package name over here inside matrix transformation factory. Now, like I mentioned, this is a Java class. The rest of the files which you see I have created, like my camera view as well as my camera view factory, those are Kotlin class. Because the reason why this class is Java is because I have copy pasted this code from the documentation and it was in Java. You can convert this to Kotlin as well, no worries about it, it will still work. But yeah, I just too lazy to convert it to Kotlin, that's why. So this should be your own package name. Rest everything you can copy it. Now even I don't really understand all this logic. So here basically we are creating this create dizzy crop effect, okay, and here we are just creating this method. Now I don't understand all this mathematical calculation, that's why I kept it as it is. But like I said, all this are from the documentation itself, so I've just literally copy pasted it from the documentation. Okay, so feel free to pause the video and just copy all this code. Then you need to go to main activity.kt, and here again I have just these are all the imports which you again need to copy. You will only see this particular part at the start, okay, so you'll have to write a lot of code as well. So first one is for requesting the camera permission. This method channel result is for sending the result back to Flutter side. Then here we are overriding this method if the request code is permission granted, and if we have this helper method as well just to check whether all permissions was granted, then we send back true, else we send back false. Here we have this configure Flutter engine method as well, where we just register our view factory. Here is our my camera view factory as well, okay. Then here we have this method channel where again this is for camera permission as well. So once you call this from Dart, we call this particular method, right, if you remember, which will call the camera permission, and once the user grants the permission, the callback comes over here. Okay, so this is all the code there is in this particular file. Now if you see the register view factory, we are calling another Kotlin file called my camera view factory, so we need to create that particular Kotlin file called my camera view factory.kt. Now this is boilerplate code which you have to write every time you want to embed a native Android view inside your Flutter application. So feel free to pause the video. The package name will be different, rest everything you just have to copy paste. There is nothing to understand over here. So we are just importing extending from platform views factory as well. So yeah, nothing much over here. Feel free to pause the video and just copy all this code. But here you can see we are referencing another Kotlin file called my camera view, so we have created that as well. So this is quite big. So firstly this should be your package name. Now there are a lot of imports, so feel free to pause the video and just copy all these imports. Then I have this @unstable annotation as well. Here we have this image capture, here we have process camera provider, here we have constraint layout, here we have preview view, here we have our button, here we have the method channel as well, here we have the executor service. Then this is the file name format. Then here we have the layout params as well, which I set it to our constraint layout. Then here we have the constraint set. Then here we just constrain our camera to all sides of the screen, but from the bottom we leave a margin of 200. Then here we have the button as well, where we constrain our button to bottom of the screen. Then we add one click listener to our button as well, and here we call the setup camera. Inside setup camera we just start our camera as well as initialize our camera executor. Here we have this take photo button, where we have the image capture, and then we have the simple date format as well. Then we have content values, where we apply the display name as well as the MIME type, and if Android version greater than P, we also set the relative path. Then here we have image capture.output file option. Then we do image capture.take picture over at the on error as well as on image saved, and here we invoke this send from native. Okay, we get the URI of the captured image with the help of this particular helper method called get path from URI. and send it back to Flutter side. Here we shut down our camera executor as well as unbind our camera provider. Then here we have this view where we return our constraint layout. Here we override this dispose method as well, where we do camera executor dot shutdown. Then here we have our start camera method, where we do create our aspect ratio strategy. Here is our resolution selector as well. Here is our process camera provider dot get instance. Then we do add our listener to our camera provider future. Here is our preview view as well. Here is our image capture. Then here we get hold of our default back camera. Then here we do use case group builder dot add preview use case as well as image capture. Here is our media 3 effect, and here you can see we are setting the effects for our media 3 by doing matrix transformation factory dot create dizzy crop effect. Okay, then we do use case group builder dot add effect media 3 effect. Then we unbind our camera, bind it to the life cycle, and yeah, that's it. Here we just pass context compat dot get main executor. Now let me check what was really causing the issue and get back to you. Okay guys, so I have figured out the issue. The issue was because my matrix transformation factory was in Java. Now typically this should not happen because it's the same setup which I used in my native Android application tutorial as well, where most of the files were in Kotlin and one file was in Java. But this is some weird Flutter issue which has been getting caused because of this Java file. So what you need to do is just change the extension of the file from .java to .kt, and here is the updated code. You will have to change it slightly. Yeah, sorry about that again, but I feel like more than like this is not really an issue from my side, it's issue from Flutter. Like this kind of setup even works in a native Android application. I'm pretty sure about that because I have made a video about it as well. But I think in Flutter you require all the files in Kotlin, given that our main project is set up in Kotlin for Android. That's why. So all you need to do is just change the extension to .kt, and here is the updated code, so you'll have to change it accordingly. Yeah, sorry about that. Now let's run our application and show you guys the output. Guys, so here is the code. I'll just give the camera permission, and here you can see this is the dizzy crop effect. Again, I'm mirroring my device, so the output might be a little bit laggy, and some of you might even get motion sickness due to this. So I'll just click on take photo, and it will capture the photo for me and display this inside an image view. Again, this is lagging a bit, but here you can see the image. So yeah, that's it. Thank you for watching. Bye.